Our objective today is to map the transition from basic PCI rate of 130 kg per ton hot metal to ultra advanced rate exceeding 220 or 230 kg per ton hot metal. Moving to high rate injection is the primary metallurgical lever we have to reduce hot metal cost and extend the life of aging coke ovens. However, as we push beyond the 200 threshold, we face a step change in complexity regarding chemical kinetics and furnace stability. At these advanced levels, our primary technical constraints shift towards managing unburned char accumulation and maintaining deadman permeability. Successful implementation require a holistic strategy involving lance design, number one, thermodynamics, and digital control. So all area is to attack together simultaneously. Coming to our advanced lance technology, that is, to maximize PCI, we must move away from the traditional single pipe lances which often cause localized oxygen starvation at high rates. We recommend transitioning to oxy-coal coaxial or eccentric double lances to enhance coal dispersion. Eccentric double lances specifically arrange lances unsymmetrically to prevent coal flows collisions which can increase combustion efficiency by more than 15% compared to single lance. So by introducing oxygen directly into the coal plum through this advanced design, we accelerate ignition and minimize the generation of unburnt char. These improved mixing ensure that the coal utilizes the oxygen in the hot blast more effectively, and unless until this is effectively used, a result cannot be enhanced. Coming to the high temperature and oxygen levers, so high PCI rates naturally have a cooling effect on the raceway that we must offset. To maintain a stable operation, technical experts should target blast temperatures above 1200 degrees centigrade. There is no doubt about it. Simultaneously, we must also utilize aggressive oxygen enrichment level of 30% to 35%. So this enrichment is critical because it accelerates combustion kinetics and manage the overall gas volume within the furnace. So higher oxygen availability is essential to ensure that unburned coal doesn't accumulate later in the coke layers or the dead man. So by balancing these levers, we maintain the theoretical flame temperature, that is raft or raceway adiabatic flame temperature, we can say, necessary for high intensity iron making. Now coming to the transition to the dense phase conveying and the mechanical delivery of the coal, as you all know, is as important as combustion itself. So we advise transitioning from dilute phase to dense phase conveying to maximize efficiency. So dense phase system achieve much higher gas loading up to 70 kg of coal per kg of gas compared to just 10 kg per kg in dilute system. So this high loading minimizes the ingress of coal nitrogen or transport gas into the tuer, protecting the thermal state of the furnace better. Additionally, dense phase system operate at much lower velocity, that is 2 to 6 meter per second, which virtually eliminate wear on transport pipe compared to the high wear velocity of dilute phase system. And now coming to one of the important aspect about burden and coke management, as PCI rates increases, the coke layer becomes thinner, putting more mechanical stress on the remaining coke. So therefore, we must maintain coke CSR level above 65 to ensure the structural support for the burden. We also recommend center coke charging to keep the furnace center, the dead man open for the gas flow. This practice prevents the center from becoming a stagnant plug that would otherwise force liquid to the periphery, aiming for an inverse V cohesive zone shape through precise burden distribution is the preferred method to maintain the stable gas permeability at this high injection rate. And uh, uh, these all are important, that what we have discussed in the 5 slide. But at the same time, coming to the digital optimization and AI control, finally, pushing PCI to its true kinetic limit requires a digital layer of protection. So AI-driven predictive model can now forecast hot metal temperature and silicon content 6 to 8 hours before the tapping. So this system use soft sensing and computer vision to monitor the raceway state in real time, detecting blockages or channeling 15 to 30 minutes before they are visible to operators. So by implementing closed loop control, AI can stabilize the furnace, reducing thermal variability to a tight band of plus minus 5 degrees centigrade to plus minus 15 degrees centigrade. This level of digital autonomy allows us to push towards a ultra advanced goal of 290 kg per ton hot metal with the minimum risk.